Hi, today we are going to understand how a binary number is converted into decimals. In data structure subject, it is a very common question that is asked, please convert a binary number into decimal. For converting a binary number into decimal, we'll be taking the help of a queue structure. I assume that you must have seen my earlier videos of the benefits of queue and how the queue is implemented using arrays. If you haven't seen those videos, please follow the link that is provided in the description below and watch those videos. You'll be able to understand this program better. Before understanding this program, we'll understand how manually a binary number is converted into decimal. See, this is the procedure. Suppose the user enters 1101. You want to convert this binary number 1101 into decimals. So the first step is to individually divide these binary digits into bits, and we will place every bit into a queue. Like this 1101 is divided by 10 and the remainder is placed into the queue. This 1 is placed into the queue. While working with the queue, two pointers are used. One is front and another is rear. Additions are done with the help of a rear and deletions from the queue are done with the help of front, right? So this remainder is added over here. After that, this 110 is again divided by 10. The remainder is 0. Again it is placed into the queue with the help of the rear pointer. The control will come over here again. This 11 is divided by 10. The remainder is 1. Again 1 is added with the help of the rear pointer to the queue. See, the rear is incrementing from 0, 1, 2, that way. The last digit 1, it cannot be divided by 10. The whole digit 1 is placed into the queue with the help of the rear pointer. Okay. So this binary number is individually divided into bits and placed into the queue. Now we will take out every bit from the queue and will multiply it by 2 to the exponents. How? This 1 is taken out from the queue with the help of the front pointer and it is multiplied by the 2 to the power 0. This 0 is taken out from the queue. 0 into 2 to the power 1. See, the power, the exponent is incrementing by 1 every time when you move to the left. This 1 is taken out and it is multiplied by 2 to the power 2. This 1 is taken out from the queue again. It is multiplied by 2 to the power 3. This 1 is multiplied by 2 to the power 0. Anything to the power 0 is 1. 1 into 1 is 1. 0 into 2 to the power 1. 2 to the power 1 is 2. Into 0 is 0. 2 to the power 2 is 4. 4 into 1 is 4. 2 to the power 3 is 8. 8 into 1 is 8. 8 plus 4 plus 0 plus 1 is 13. So the decimal version of this binary 1101 is 13. Now let's do it through a program. As I said, in the queue, you will be requiring two pointers, front and rear. Both are initialized to -1. These are two method prototypes. One is addQ and another is delQ. Obviously, addQ method will be called to add the binary digit into the queue, and delQ method will be called to take out, to remove the bit from the queue. This max is a macro defined as 10. Because I'm defining the queue of length 10 elements, I assume that the user won't be entering binary number of more than 10 digits. If you think so, you can increment this value to 15 or 20, whatever it is. User is asked to enter a number in binary. Suppose user enters 1101. This 1101 will be assigned to this binnum variable. This binnum variable 1101 is temporarily assigned to a temp variable. This while loop will execute for the time this 1101 is more than 0. Is 1101, that is 1101, is it more than 0? Yes. This 1101 is divided by 10. See, this is the mod operator. It divides a number and returns the remainder. When 1101 is divided by 10, the remainder will be 1, that is assigned to this remainder variable. AddQ method is called and you are taking this Q array and the remainder, that is 1. The addQ method is written after this main function, but I have copied it over here for your reference. This Q will be assigned to this Q array. This 1, remainder 1 will be assigned to this value parameter. Rear is incremented. Rear is -1. It is incremented to 0. To this Q0 you assign this 1. To this Q0 this 1 is assigned. Is front -1? Yes. This rear, that is, this 0 value is assigned to front also. That is, when the first value is added, front and rear will point to the same value, right? So front and rear both are 0. Control will come over here. 1101 is divided by 10. The answer is 110.1. But in C, when you divide two integers, the answer is truncated to an integer. So the fraction 0.1 is truncated. Only 110 is assigned to binnum. Control will go into the while loop. We'll check this logical expression. Is 110 more than 0? Yes. 110 is again divided by 10 and the remainder is assigned to remainder variable. 110 when divided by 10 the remainder is 0, that is assigned to this remainder variable. AddQ method is called. Control will come over here. The remainder 0 is assigned to this value parameter. Rear plus plus. Rear was 0. Rear will become 1. To this Q1 value you assign this 0. This is assigned. Is front minus 1? No. So front will remain to this location. Only rear is incremented. That is, all the values are added with the help of the rear. Front will keep pointing to the first value because this is the value to be removed first, right? Control will come over here. 11 divided by 10. The result will be 11.0, but it will be truncated to 11, that is 11. That will be assigned to this bin num variable. Again, while loop is checked for the logical expression. The logical expression is true because 11 is greater than 0. 11 divided by 10 and the remainder is assigned to remainder variable. Remainder will get the value 1. AddQ method is called. This Q and 1 will be assigned to these two parameters. Rear, which was 1, it is incremented to 2. To the Q2 value, this 1 is assigned. Q2, 1 is assigned. Is front equal to minus 1? No. Control will come over here. 11 divided by 10. The answer is 1.1. It is truncated to 1. The while loop again will execute. 1 greater than 0. Yes. 1 is divided by 10 and the remainder is assigned to remainder variable. 1 cannot be divided by 10. So the whole 1 digit is assigned to remainder. Again AddQ method is called. This Q will be assigned to this Q array. This 1 will be assigned to value parameter. Rear is 2. It will be incremented to 3. To this Q3 you are assigning this value, that is you are assigning this 1 value. This will be assigned here. Is front minus 1? No. Control will come over here. 1 is divided by 10, the answer is 0.1. It will be truncated to 0. That will be assigned to this bin num variable. Again this logical expression is checked. Is 0 greater than 0? No. So the control will exit from this while loop. On the screen you get the decimal conversion of the binary number 1101 is, now you can see that why that number was temporarily assigned to this temp variable, right? Now you are calling the delq method. Delq method is written over here and I have copied the main function for your reference over here. Delq method is called and this Q is assigned to this Q array. Now you will be taking out 1 by 1 bit from the Q and will be multiplying it by the power of 2. So right, the power variable is defined to 0 and this decnum represents the decimal number which will contain the answer for us. This is also initialized to 0. This delq method is called. This Q will be assigned to this Q array. Is front minus 1? No. Front is 0. Control will come over here. Is front and rear pointing to the same value? No. Both are different. Control will come here. Take out the value Q0 and assign it to J. Q0 has 1. It is assigned to J. Front is incremented to 1. Front will become 1. Return J. J will be assigned to this K variable. Is K not equal to hash? No. This while loop is executed for the time K is not equal to hash. K is 1. 1 into 2 to the power 0. Anything to the power 0 is 1. 1 into 1 is 1. Decnum is 0. 0 plus 1 is 1. And this result 1 is assigned to this decnum variable. Power is incremented to 1. Again delq method is called. Control will come over here. Is front minus 1? No. Front is 1. Is front and rear same? No. Q1 value is taken out and assigned to J. J will get the value 0. Front is incremented to 2. This 0 will be assigned to this K variable. Is K not equal to hash? Yes, it is not hash. 0 into 2 to the power 1. Anything multiplied by 0 is 0. 0 plus 1 is 1. Decnum will retain the value 1. Power is incremented to 2. delq method is again called. Q will be assigned to this array. Is front minus 1? No. Is front and rear pointing to the same value? No. This Q2 is taken out and assigned to this J variable, right? Again delq method is called. Is front minus 1? No. Front is 2. Is front and rear same? Are they pointing to the same value? No. This Q2 value is taken out and assigned to J. So J will get the value 1. Front value will be incremented to 3. Return J. This 1 will go back to the main function, will be assigned to this K. So K is 1. Is K not equal to hash? No, it is not. Decnum is 1 and the power is 2. Decnum is still 1, right? So 1 into 2 to the power 2. Power has become 2, right? So 2 to the power 2 is 4. 4 into 1 is 4. 4 plus 1 is 5. And that 5 is assigned to this DACnum variable. Right? Power is incremented to 3. Again, del Q method is called. And Q is taken along with. Q is assigned to this Q array. Is front -1? No. Is front and rear pointing to the same value? Yes. So what will happen? Q front, that is Q3 is taken out, assigned to this J, and both front and rear will be initialized to -1 to indicate that the Q is empty. J will have the value 1 because if block is executed, so else block won't execute, return J. This 1 will be assigned to this K variable. Is K not equal to hash? Yes, it is not. DACnum is 5, right? And 1 into 2 to the power 3. 2 to the power 3 is 8. 8 into 1 is 8. 8 plus 5 is 13. 13 is assigned to this DACnum variable. Power is incremented to 4. Del Q method is called. Control will come over here. Is front equal to -1? Yes. So it will return hash. Hash will be assigned to this variable K. The while loop will execute for the time K is not equal to hash, but this time the K is hash. So this while loop will terminate. Control will come over here and will display the value of DACnum variable, which is 13. So this program is working perfectly well. We'll run this program. I'm using Kigwin software tool for running my C program. Kigwin is a software package that gets you the Unix environment in Windows. Let me tell you that the Unix operating system is written in C, so you can run the C programs also in Unix. I have already written the program for you. See, I have already written this program for you to decimal.c, right? This is the program that we discussed. Right. I'm compiling this program. I'm using GCC compiler for compiling my program. No errors, only warning. So this program is working perfectly well. Let's run this. Enter a number in binary. Let's enter 1101. See, the decimal conversion of binary number is 1101. Can you see that? Let's run it again. Let's enter a big number. See, the binary conversion of this number is 101. So this program is working perfectly well. If you want any help, you can mail me at bmharwani@yahoo.com. For the code of this program, you can see the link in the description below this video. Thanks for watching the video. Have a nice day.